Periodic properties of elements. Here we are discussing the atomic radius and ionic radius. Okay, most of the properties of elements like atomic size or atomic radius, then valency, ionization energy, electron affinity, etc. are directly related to the electronic configuration. That is, the properties depends upon the number of valence electrons present. Okay, so these properties shows periodic variation with atomic number in a period or a group. So first let us discuss atomic radius, or we can say atomic size. Atomic size. Okay, so atomic size of an atom is assumed to be spherical in shape. Okay, size of an atom is spherical in shape. So we have to determine the radius in order to determine its size. Okay, in order to determine its size, we have to calculate the radius, because atom is assumed to be spherical in shape. Okay, so what is atomic radius? Atomic radius, it is defined as the distance from the center of the nucleus to the outermost shell of electrons. Okay, it is defined as the distance from the center of nucleus. Okay, center of nucleus to the outermost shell of electrons. Outermost shell of electrons. Okay. This distance is called as the atomic radius. So if we calculate the atomic radius, we can determine the size of an atom. Okay, so atomic radius can be calculated in different methods like X-ray diffraction method, then spectroscopic method, etc. are used to find the atomic radius. That is, approximate atomic radius can be calculated by using these different spectroscopic methods and X-ray diffraction. Okay. Next, atomic size can be expressed in different types of radii. Okay. There are different types of radii. Okay. They are, first one is covalent radii. Then van der Waals radii, and metallic radii. Now let us discuss one by one. The first one is covalent radius. So we know the internuclear distance is the distance between the nuclei of two bonded atoms. Okay, so radius will be half of the distance between the that is half the internuclear distance. Okay, so how can we define covalent radius? Covalent radius is defined as the one half of the distance between the centers of the nuclei of two similar atoms which are bonded by a singly covalent bond. Okay, so it is defined as half of the distance between the centers of the nuclei of two similar atoms. Okay, two similar atoms which are bonded by a singly covalent bond. Okay, single covalent bond. Okay, so here this will be the half the distance will be this much. So this will be the covalent radii. Let us take one example in the case of Cl2. Internuclear distance is is 198 pm, and half the distance will be the covalent radius. So covalent radius equal 99 p. Okay, this will be the covalent radius. Like this, we can find the covalent radius. Second one, van der Waals radius. Okay, so van der Waals radius is 1/2 of the internuclear distance between two non-bonded atoms of adjacent molecule of the element in the solid state. Okay, 1/2 of the distance between two non-bonded atoms. Okay, two non-bonded atoms of adjacent molecule. Okay, of adjacent molecule of the element in the solid state. Of the element in the solid state. Okay, so this is in the case of non-bonded atoms. So van der Waals radius will be always greater than covalent radius. Okay, now the third one is metallic radius. Metallic radius is 1/2 of the distance between two adjacent atoms in the metallic lattice. In the case of metals, we will take the metallic radius. Okay, 1/2 of the distance between 1/2 of the distance between two adjacent atoms in the crystal lattice. Okay, this radius is also called as crystal radius. Okay, also called as crystal radius. Okay, and this metallic radius also will be always greater than the covalent radius. Okay. Next, what will happen to the atomic radius in a period and a group? In the case of a period, atomic radius decreases in a period. So atomic radius decreases from left to right because the electrons are added to the same shell, so effective nuclear charge is increased. Okay, next, what will happen in the case of a group? Atomic radius increases from top to bottom. This is because the effective nuclear charge decreases because electrons are added to the new shells in a group. So there will be shielding effect, that is inner electrons or inner shells shield the electrons, the outermost electrons, and as a result the effective nuclear charge decreases. So as the effective nuclear charge decreases, the atomic radius increases. So size of the atom increases in a group from top to bottom. Then in the case of noble gases, what will happen? Noble gases. Noble gases are monoatomic species. Okay, because they have stable electronic configuration, so they are monoatomic. In the case of monoatomic atoms, the radius will be van der Waals radius. Van der Waals radius. Van der Waals radius is the radius of two non-bonded atoms. So van der Waals radius will be always larger than the size of the always larger than the covalent radii. So in the case of noble gases, we had to consider van der Waals radius instead of this covalent radius. Okay, so these noble gases will have bigger size, or atomic radius is more than that of the other periods like the 17th group, 16th group, etc. Okay. Next, ionic radius. Ionic radius means the radius of ions like cations and anions. First, what will happen in the case of cations? In the case of cations, they have fewer electrons than parent atom. Okay, so they have smaller size. Smaller size. This is due to the increase in nuclear charge than the parent atom. Okay, so cations have smaller size and radius, ionic radius is smaller than parent atom. Next, in the case of anions, anions are obtained by the addition of electrons. So, size increases or ionic radius increases. This is because as the addition of electrons, there is decrease in the effective nuclear charge. Decrease in effective nuclear charge. Okay. So, as the number of electrons increases, there is repulsion between the electrons. So, decrease in effective charge, effective nuclear charge. So, what will happen? Size increases or radius, ionic radius increases. Ionic radius is greater than parent. Okay. And the ionic radius has the same trend as in the case of atomic radii. Now, let us take few examples. Ionic radii of F minus, fluorine, it's an anion. Calculated value is 136 pm. And atomic radius of fluorine atom. This is found to be 64 pm. So, from this we can see that the ionic radii is greater than the atomic radius. This is because of the bigger size. Then, what will happen? Ionic radii of sodium, Na, is found to be 186 pm. But in the case of Na plus is an ion. It is a cation. So, normally its size decreases. So, its radius, ionic radius also decreases. So, it's found to be 95 pm. Okay. These are the two examples for ionic radius. Okay. Now, we are discussing about isoelectronic species. Isoelectronic species are atoms or ions contain same number of electrons. Okay, contains same number of electrons. Let us take few examples. O2 minus, F minus, Na plus and Mg2 plus. So, a few examples. Okay. Their nuclear charge, they have the same number of electrons, but their nuclear charges are different. So, what will happen? Their radii are different. So, atomic radii will be in the order O2 minus is having the bigger size, then F minus, then Na plus, Mg2 plus. Cations are having smaller size compared to the anions. Okay, anions with higher charge will have more size and cations with higher charge will have smaller size. Okay, this will be the order. Okay.